It's a weird section. It's kind of abstract because there's so many letters in the equation. But it will truly tell me if you really understand solving. Do you really get solving? Because you're going to solve using the methods that you know. To undo addition, you use subtraction. To undo subtraction, you use addition. To undo multiplication, division, and to undo division, multiplication. So all those rules are still applying. But it looks weird because it's not just x and things like that. You can't combine things like we've been able to. Okay? Two very important things, as I have there. As it says, two important things. If there is a fraction, you have to get rid of it first. That has to be step one, or you're going to make it too hard. So if there's a fraction, we're going to get rid of it. Step one. It doesn't matter what you're solving for, that needs to be the first step. The second piece, if the variable you're solving for appears more than once, you may have to factor. Okay? Now, that might not make sense right now, but when we get to that question, I will make sure I re-emphasize number 2. When does that happen? Okay, so question number 1. There's a fraction. So get rid of it first. Multiply both sides by that denominator. You won't necessarily have to search for a common denominator because there's only going to be one denominator. Okay? So multiply both sides by r. So on the left, I get rs. Or SR, the order that you write it would not matter because it's multiplication. On the right, the R's cancel, and I'm left with V. All right, now we're going to worry about what we're solving for. We're starting with the easier ones. I'm solving for R. So if I want to get R by itself, what am I going to do with S? Grace?
Divide it.
Divide. Divide by S. Divide by S. R is now alone. That is my answer.
Why would you divide by r? I mean, like, get the r by itself.
Because that's what they're gonna tell you which one. They're gonna tell you which variable they want by itself. Because I could change it. Like on this next question, I could make an A, little a, or I could make an H. In fact, you're gonna think on some of these questions, like when you do your OTL, that we did it already, but it's because I just changed the letter that you're solving for. Okay, second example. I am solving for H. So I have A equals 2 little a squared plus 4AH. Big A, little a, not the same thing. So this is my H term, the 4AH. So what am I going to do first to get 4AH by itself? Subtract 2a squared. So this is what I mean by using your solving, knowing how to isolate a term, using those correct steps. Now, on the left, where I have a minus 2a squared. Up to this point in our solving, when we have done that, we've literally been able to subtract because they have been like terms. Here, that is not going to be the case. So I can't literally subtract a minus 2a squared, so I write it as a minus 2a squared. Equals 4AH. Solving for H. What am I going to do to get that H alone? What's going on with 4 and A and H right now? Multiplication. So I'm going to get rid of them by dividing by 4 and A. There's my answer. I will tell you now that when you do a division on these at the end, don't go any further. You cannot cancel out or reduce those little a's here. At least in a manner that you know how to at this point. Okay, my next question has a fraction. So step 1 is to get rid of it no matter what you're solving for. You have a denominator of 2 that I have to get rid of, so I'm going to multiply both sides by 2. So on the left I have 2 times m. 2m equals, on the right my 2's cancel, that's why I did it, and I have x plus y. Okay, I want that x alone. I want it to say x equals, so what am I going to do to get rid of that plus y?
Divide by, or minus y.
Minus the y. And once again, you can't literally subtract 2m minus y. So I write it as 2m minus y equals x. There's my answer. I have a fraction on my next one. There's only one denominator, so both terms times that denominator of 2. So on the left, I have 2s. On the right, the 2's cancel, and I'm left with n times the quantity a plus l. That is an L. When you type an L, it ends up almost looking like a 1. Be careful in your OTL because there's a problem that has an L and a 1. So you got to really know which one's which. You can change it to a capital L if you want to. I don't think there's capital L's in it. Okay, we're solving for A, and A is inside the parentheses, which means we have to get it out of the parentheses. So we're going to distribute. N times A is NA, AN, whatever you want to write, doesn't matter. N times L, NL, LN, it doesn't matter. Solving for A. How do I get the A term? This is the A term, NA is the A term. How do I get that by itself? So first I have to get rid of plus NL. Subtract it. Now I can't literally subtract 2s minus NL, so I write it as 2s minus NL equals NA. Solving for solving for A. So the next thing I'm going to do, the last thing I'm going to do is to divide by n. And again, those n's won't cancel. Don't do it. Once you do that division, leave it. Okay, some questions so far. Anything you want to ask so far, because the last 3 are harder. Okay, I want to take a second to look at this last one we just did, because we're going to use this concept in our next question. Here we had n times this quantity, and we distributed to get rid of the parentheses. Now you'll notice that you only see n once in this line or this expression right here. But when I distribute, I now see n 2 times. Okay? So that piece at the beginning where I said, if the variable you are solving for appears more than once, you're going to have to factor. And that's what factoring is. Well, there's a lot to factoring. We cover a whole goal on factoring. But the first part of that goal is this. You can take an expression and go backwards. So here we distributed to get rid of the parentheses, but I could go from here to here and put parentheses back in. And that's exactly what we're going to do. Because here I see n twice, but if I do this, I can see n once. So n, which is the common factor to both of these things, comes out in front. And then what's left after I take n away is what's in the parentheses. That's just called pulling out a common factor. That's the concept we're going to use now. We're going to do the opposite of our distributive property. So you're going to see that in this next question. Okay, we have a fraction first, so it doesn't matter what we're solving for yet. Get rid of it by multiplying both sides by that denominator. So I have n times a. N cancels over here, and I have left 180 times n minus 2. So we're solving for n. I have an n here and I have an n here. One of the n's is in parentheses, so I got to get it out of the parentheses. So we'll do that first. So 180 times n is 180n. 180 times minus 2 is minus 360. Now, if we were solving an equation for x, and you had x on both sides of the equation, you would have to get them to one side. So the same is true here. I'm solving for n, and I have n's on opposite sides of equals, so I need to get them to one side. So I will do that first by subtracting my 180n. Once again, I can't literally subtract NA minus 180n, so I write it NA minus 180n equals negative 360. The variable I'm solving for appears more than once. So this is where I do the reverse, the opposite of my distributive property. I'm going to put parentheses back in. So n is the common factor, so that comes out in the front of the parentheses. When I take n from the first one, I have a, and n from the second one, my minus 180 equals negative 360. Now we see n just once. So if you're not sure if you did it right, just double check. Redistribute n times a, n times minus 180, and you get back what you started from. But now this is n times the quantity. And to get rid of it then, because I'm multiplying n times the quantity, I can divide by the entire quantity. And I can do that because it's in a group. I don't really need to write the parentheses, but I want to emphasize that that's what's happening. Okay, so n times the quantity, so I can divide by the quantity, get rid of the whole quantity at one time. Parentheses are not necessary, but I just wanted to make sure that you saw that.